when given logarithmic expressions, remember that they have a value, and think of this as a number. A logarithm is an exponent. This is a number. This is an exponent of something. We could punch this into a calculator. What we're going to find is most calculators only have a base 10 and a base e that we're going to talk about later. But if we're trying to simplify this, if we know this is a number, let this thing equal x. That way when I get to an answer of x equals 8, x equals negative 3, that's my number. Once I have that equal in there, well, now I have my logarithmic form. I can just bounce it straight into exponential. A base of 2 to the power of x equals 32. By changing forms, exponents are something we're a little bit more comfortable with. And what's going to make these problems a little bit easier is that these will be powers of my base. 32 is, if I take 2 times 2, it's 4, times 2 is 8, times 2 is 16, times 2 again, 2 to the 5th power is 32. If you multiply 2 times itself 5 times, I get 32. And again, this just goes back to the definition of our exponent, and these are what will work out for many of these problems. What I've done is I've set up, if I have the same base, then what I know is the exponents have to be equal. It doesn't make any sense to say 2 to the power 5 is equal to 2 to the power 3. Or 2 to the power 5 is equal to 2 to the power of negative 20. If I can get the same base, I know for sure my exponents have to be equal. And if I say x equals 5, remember what x was. X was log base 2 of 32. If I punch that into a calculator, I get 5. And that's what I put in Math Excel. For my next example, it's going to be very similar, but with one subtle difference. Again, this is something I could just plug into a calculator, but I want to find its value. If I let it equal x, in my logarithmic form, I can just rearrange. 2 to the power of x equals 1 over 8. Changing the form, we're more familiar with exponents. One thing that I should observe, the way I get that 1 over, is the fact that I'm going to have a negative exponent. And this is kind of working my exponents backwards. When I saw that negative exponents, that's what would have made me put 1 over whatever, right? Take the reciprocal and put it in the bottom. Well, that's what I'm working backwards. Now, I recognize that since it's in the bottom, is because it's negative. As bad as I want to say 4, remember it's 2 to the 3rd power because it's 2 cubed that gives me 8. I don't want to try multiplying or dividing. The first day of class, had I been given 2 to the power negative 3, what I would have said was 1 over and make the exponent positive. Take the reciprocal and give it a positive exponent. And when I see 2 cubed, 2 to the 3rd power, 2 times 2 is 4, times 2 is 8. This is that same 1 over 8, but what I've done now is created this to be that same base. And if I get the same base, then I know my exponents must be equal. X must equal negative 3, meaning, well, what was x? X was log base 2 of 1/8, which is negative 3. And when we see those fractions, most of the time it will be the case that we do have that negative exponent, especially when it's just that 1 over. It's a result of the reciprocal.